Okay, so what if the roots are 3 and negative 4? Write the equation in standard form. So standard form is ax squared plus bx plus c, and we want it to equal 0. So it told us x equals 3 and it told us x equals negative 4, but we're going backwards. So we're going to set them equal to 0. So how do you move a positive 3? We subtracted 3, and we get x minus 3 equals 0. How do you move a negative 4? You plus 4, so x plus 4 equals 0. And now we know that we have both of these equal to 0. Well, to put it into standard form, we're going to double distribute. What's x times x?
X squared.
X squared. What's x times 4?
X 4.
4x. Negative 3 times x?
Negative 3x.
And what's negative 3 times 4?
Negative, I don't know,
12. Now remember, when you double distribute, the middle two terms are almost always alike. So here, what's 4x minus 3x? What's 4 minus 3? So that is what our equation would have been if our answers are 3 and negative 4. Now we can check our work. You can come here, you can type in your x squared, not minus, sorry, plus 1x minus 12, and you can go and you should have at 3, does it equal 0? Yeah, and at negative 4, does it equal 0? So we did it right. Okay? What?
I don't understand.
What don't you understand?
The last part.
From here to here?
Yeah,
We just double distributed. We multiplied. You told me everything, x times 4, negative 3 times x, negative 3 times 4, and we got this.
okay, but
These two were middle, they're the same.
yeah, those two, what's that? Like, what did you do with it?
4x minus 3x. If I give you 4x's, and then I take 3x's back, how many do you have?
So there's 1.
Yeah, so that's why it's 1x in the middle.
Okay.
We were just combining like terms.
Alright.
Okay? So then it says, think about what equation could you add 3 in for x and it equal to 0? Well, which one would 3 make equal 0? Well, if I plugged it in here, I get 3 plus 3, which equals what? 6. Now if I plug it in here, I get 3 minus 3. What does that equal? 0. So it would be that one. What about negative 4? Well, negative 4 plus 4 equals what? So if you need to, you can use your calculator. Negative 4 plus 4 is 0. So that equals 0. Here I would do negative 4 minus 4. What does that equal? So do you notice that this is a negative 4 and that's a positive 4? That's why it cancels and equals 0. Here, do you notice it's a positive 3 it was asking about and we chose the negative 3? It's because the opposite is what cancels something. Okay? We call it a 0 pair. Okay, like 4 and negative 4 are 0 pairs. Negative 2 and positive 2 are 0 pairs because they'll cancel each other if you add them. Okay? And it's because they equal 0 that we call them 0 pairs. When you pair them together, they equal 0.
Miss, you want to tell my girl to stop texting me? She's mad because I answered another girl's name. So you need to tell her to stop texting my shit.
Can you watch your mouth when I'm recording? Okay, so it says now we use those to multiply the binomials to get the standard. So which one? We had the x minus 3 and we did the x plus 4. Those are the two that we chose. And what do we do to get this to standard form?
Distribute.
We double distribute. What's x times x?
X squared.
What's x times 4? Negative 3 times x. Negative 3 times 4. So really we're just doing this all over again. So it gives us the same thing, which we already checked our work. So that is right. Okay, if the roots are 6 and 0, write the equations in standard form. Well, we know x equals 6 and x equals 0. Can I change x equals 0 at all? No, so x is one of my factors because there's no way to change that. Okay? Right? Okay, but can we change this to equal 0? What do I do? Minus 6. And what does it become? So my other factor is x minus 6. Remember we set it equal to 0. So how do I don't have to double distribute here. I'm just doing single distribution. So what's x times x? X squared. And what's x times negative 6? Now there's nothing else that can simplify, so let's check our work. X squared minus 6x, second graph. We should have one at 0, do I? And then the other one was at positive 6. Did it work? Yes. Okay, what if the roots are just 3? Well, that's telling me x equals 3. Right? Okay. And we're going to subtract 3 from both sides, and we get x minus 3 equals 0. Now, that's a linear line. Okay? I want you to realize when we've gotten this special case where it's the same number, didn't it end up happening twice, where it was the exact same? When this happens, you're literally just squaring it. Because, remember, you would get the same thing equaled twice. So we get x minus 3, x minus 3. So this is a special case. Okay, so we get x times x, which gives me what?
Miss, you got a paper clip?
X times negative 3. Negative 3 times x. And negative 3 times negative 3 is positive 9. No paper clips here.
I see one right there.
I know. Go sit down. Negative 3x minus 3x is negative 6x plus 9. And there's my standard form. Go away. I'm not kidding. Go sit down.
Let me get a paper clip. I need one, man.
Okay, now this one's a little different. So we have x equals negative 1/2, and we have x equals positive 1/3. Okay, do we ever have fractions in our standard form?
Yes.
No, we don't. Okay, so we have to get rid of that fraction. Doesn't fractions just mean negative 1 divided by 2? What do we do to get rid of division? We multiply. So I'm going to multiply both sides by 2, and that cancels that, and I have 2x equals negative 1. Now what do I do to get it equal to 0? Plus 1 on both sides. So I get 2x plus 1 equals 0. There's my factor. So what am I going to do on this one? Multiply both sides by 3. Those cancel, and I get 3x equals 1. Now what? Subtract 1 from both sides, and I get 3x minus 1 equals 0. Am I done? No, I needed to equal standard form. So what do I do first? 2x times, not plus, but times. So what's 2 times 3? 6. And what's x times x? X squared. Okay, 2x times negative 1. Well, negative 1 times 2 is negative 2, and then we have the x. 1 times 3x, well, 1 times anything is just itself, so it's going to be positive 3x. And 1 times negative 1 equals negative 1. This simplifies to positive 1x. So there's our answer. Now this one's not as simple to check your work, but it's possible. So we get 6x squared plus 1x minus 1. Okay, because if you notice, none of them are here because weren't they fractions? Do y'all remember what I told y'all yesterday to do?
Yeah, to go to the graph and put the fraction there.
No. You'll do in your table. No, yeah, you're right. Just kidding. Haha. You'll do second trace from your graph.
I'm trying so hard.
Sorry, just trace.
Cope with this class and you just
Can you stop being dramatic? Thank you. Okay, I hit graph and then I hit trace. Do you see how all that stuff pops up? And you can literally just type the x value. So negative 1 divide 2. Did it land on there? If it's hard to tell, you can zoom in. I zoomed out. Probably not the best idea. Zoom in. So now it's much better. So I can do trace. And I can type, sorry, negative 1 divide 2. Does it land right on the spot? Yeah. And does y say 0? Yeah. Okay, and then the other one was 1 divide 3. Did it land there with y equals 0? Yes, so those are right. So when they're fractions, you can't check them in the table as easy, but you can on the graph. Okay, so you have practice. There's 9 practice problems. Okay, so this is what you're working on. If you finish 6 of them, you can be done. If I see you on your phones, I'm going to take them.